I hope you're all doing great. I am Mr. H. Thank you for joining me. We're looking here at this solving trigonometric expression cosine x is equal to tan x. If you were tasked with solving this, what could you do, or how could you go about doing it? If you were to look at this in terms of a graph, you have a cosine. We can look at everything here from a very limited domain. How about minus pi over 2 to positive pi over 2? Just keep it to a limited domain, and that's exactly your cosine function here with the 0, 1 y-intercept. How about the tan function? Well, you know the tan of 0 is always 0. It goes to the origin. It would come down looking like this. It has a pi over 2 minus pi over 2 vertical asymptotes. But right here, at this specific point, you'd have a solution. There's a specific x-axis value here. That's your solution. And how would you go about determining that? It would have a good y value here. We can also determine that as well. How would you go about doing that? You can start with exactly what you have here. Cosine x is equal to tan x. And then you can take this onto the other side. Cosine x minus tan x is equal to 0. And now you have an expression you can work with. You'll have to switch this tan x into its functions. Sine x divided by cosine x is equal to 0. And do a common denominator, and that'll help you along. You have a cosine x over here. 1 goes in cosine x times, you'll multiply and you get cosine square x minus sine x is equal to 0. You can take this across and zero it out. You'll have cosine square x minus sine x is equal to 0. What can you do here? You have two different items. How about you use this identity and convert everything into one item? Sine square x plus cosine square x is equal to 1. Cosine square x is equal to 1 minus sine square x. And that's what I would do. I would substitute that for right over here. I'd have 1 minus sine square x minus sine x is equal to 0. I would open this up and I'd have a quadratic equation. Minus sine square x minus sine x plus 1 is equal to 0. I can multiply everything here with a minus 1. And I can flip the signs around. I'll have a sine square x plus sine x minus 1 is equal to 0. And that's my quadratic equation, which will help me enable that point. I can do a substitution. How about this? If u is equal to sine x, then I'm really looking at u squared plus u minus 1 equals 0. And now use a quadratic formula. You have a, b, and a c. You'll have a minus 1 plus minus square root of 1 square minus 4 times 1 times minus 1 divided by 2. Minus b plus minus square root b square minus 4ac divided by 2a, and you're good. When you compute all of this, you'll have minus 1 plus minus root of 5 divided by 2. This will give you two answers or two values. You have to look for both of those values. Bring your calculator. Negative 1 minus 5 root divided by 2, you're getting a minus 1.618. That's perhaps one solution, minus 1.618. And then the other one you do with the positive. You do negative 1 plus root 5 divided by 2, you get 0.618. Now the problem is this. You have two solutions here, temporary solutions, but you have to put them over here. Sine x is equal to that, sine x is equal to this. The only problem is for sine, the sine has a range only from minus 1 up to 1. So this is outside the range of the sine function. So you can only proceed with this one right here, 0.618. The other one has to go out. Sine x is equal to 0.618, and then x is equal to inverse sine 0.618. You have the 0.618 saved. Do inverse sine and you get 38.172 degrees. 38.172. Now the thing is, here we've put everything here in radians. You know this right here is equal to 90 degrees, but I want to switch this to radians. I have 38.172. How do I switch this into radians? I'll multiply this by pi divided by 180. You know how to convert from radians to degrees or degrees to radians. Degrees you multiply by pi over 180. I have 38.172 degrees. I'll multiply by pi and I'll divide it by 180, and that'll give me my radians, 0.6662. This value here will be 0.6662. That's your x value. How will you determine the y value? Well, you can take this 0.6662 and do the cosine or the tan of it. But before you do that, you have to shift the mode to radians. Hit mode and then 5. You've converted to the RAD mode. Now, you can save this value. I'll save it. You can do the cosine of this. You get 0.786, or you can do the tan of it, 0.786. And that would be your y value, 0.786. So let me put the intersection point or this solution for you right here. It's going to be 0.6662, comma 0.786. That right there is your answer. What is the solution of this particular expression right here within this domain minus 90 to 90? It's really this 0.6662, which translates, as you know, to those degrees, 38.172 degrees. Here I've just converted everything into rads. You know rads, and that's everything is converted into rads. And that's how you'd want to do it, because here my graph is in terms of radians. So it's 0.6662 radians, comma, your y value, your output 0.786, and the answer would be right. And this question has been completed. Remember, always see if your answer should be in terms of degrees or if it should be in terms of radians. And you would know that by means of looking at your graph. If these x values are represented in terms of angles, then keep your answer in degrees. If they're represented in terms of radians, convert to radians, and you'd have to use this mode and then 5. You'd get the RAD right here, and that'd be your radians. But this question has been completed. Thank you for watching. Have a great day. Bye.